6.3 multiplication of a vector by a scalar. For a vector k times vector v, where k is scalar and v is a non-zero vector. If k is a positive number, okay, let's say 5, okay, so k times v is in the same direction as v. So if k is 5, v and 5v has the same direction, and the magnitude is k times magnitude of v. Let's say if magnitude of v is 10, if k is 5, the magnitude of 5v is going to be 5 times 10, 50. If k is a negative number, let's say negative 4, okay, then k times v is opposite, is in the opposite direction as v. So negative 4v is opposite to v. And the magnitude is absolute value of k times magnitude of v. So again, if the magnitude of v is 10, k is negative 4, then the magnitude of negative 4v is going to be 40. Okay, so the absolute value of negative 4 is 4. And if the magnitude of v is 10, then you get 40 for the magnitude of negative 4v. Okay, so let's do some practice questions. Example 1, given the vector v, draw the following vectors. So we're going to draw 2v. So this is v. So 2v is going to have same direction as v, but the size or magnitude of it is going to be 2 times v. So make sure pay attention to the slope of the vector. Okay, so 2v. Let's say I'm drawing it here. So this would be 1v, and this would be 2v. And the direction will be same as v, 2v. So let's draw negative 3v. The size is going to be 3 times of v. The slope is the same. Let me start from here. So 1v, 2v, 3v, and since it is negative, the direction is going to be opposite to v. So that is the direction. So negative 3v. So c is half v. So it is positive. It will have same direction as v. And the size of half v is going to be half of the magnitude of v. So this is half. So 1 over 2v. So let's look at collinear vectors. When two vectors are parallel or lie on the same straight line, these vectors are collinear. The terms parallel and collinear can be used interchangeably. So they mean the same thing. So vectors u and v are collinear if and only if it is possible to find a non-zero scalar k such that u equals k times v. So this means you can write one vector in terms of other vector. Let's say you can write u vector in terms of v by multiplying it by a scalar negative 2. Okay, so this means that u and v are collinear. In this case, they have opposite direction because this is negative, but again, to be collinear or parallel, they don't have to have the same direction. They may also have opposite directions. So what is a zero vector? So the vector with a magnitude of 0 and no defined direction. And that's how we show zero vector. So make sure you have, again, the symbol, vector symbol on top of 0 to represent that it's a zero vector. 0 if you just write 0, again, this is just a scalar. You have to put this arrow, little arrow, to show that it is a 0 vector. Okay, so if you multiply any vector with a 0, you don't get 0, but you get a 0 vector. Okay, and let's say we have AB plus BC plus CA vector. So AB plus BC plus CA vector. So if you add those three, so as you see, you go from A, you start from A and you end at A. So actually you end up with a 0 vector. Okay, so and we learned that shortcut before. So you end up with AA vector, and AA vector is a 0 vector, or BB vector, doesn't matter. Let's look at the definition of a unit vector. A unit vector is a vector having a magnitude of 1. So magnitude of unit vector is 1. For any vector v, a unit vector parallel to v is given by, so this represents a unit vector. So you see a little party head. Therefore, I say unit vectors love to party. Okay. And how do you get that unit vector which has the same direction as v? You take v vector and you divide it by the magnitude of v. So let me give you a simple example. Let's say we have a velocity vector 50 kilometers per hour towards east. So how do you get the unit vector that has same direction as this? You take this and you divide this by the magnitude of this vector, which is 50. Then unit vector is 1 kilometers per hour towards east. Okay. Let's look at example 2. If x and y are two unit vectors with an angle of 30 degrees between them, find the magnitude and direction of the vector 3x minus 5y. So you have x and y vector. They are unit vectors, so magnitudes of them are 1, and the angle between them is 30 degrees. So you want to look at 3x minus 5y. So I'm going to draw, let me do it here. So 3x, 1, 2, 3. So this is 3x vector. And I need 5y. So 1, 2, 3, 4, 5. So this is 5y vector. And I'm looking for here 3x minus 5y. So they are tail to tail. Of course, when I multiply them, the angle between them doesn't change. It's still 30 degrees. So 3x minus 5, you start from the head of the negative vector and go to the head of the positive vector. That is 3x minus 5y. Okay, so now we are going to do the calculations. So magnitude of 3x minus 5y squared. Again, we are going to use a cosine law here. Let me draw this triangle one more time here. So 3x, x is a unit vector, so means that magnitude is 1. So 3 times 1, then this side is going to be 3 units. Again, y is a unit vector, So magnitude of it is 1 multiplied by 5. So this side is 5 units. And this is the magnitude of 3x minus 5y. And the angle is here 30 degrees. So then we use cosine law here. 3 square plus 5 square minus 2 times 3 times 5 times cosine 30. So we get here 9, 25, 34 minus, if you multiply 15, root 3 over 2. Okay, so 15 root 3. Let's calculate the approximate value. 34 minus 15 root 3, 8.01, but that is the square of the magnitude. So we are going to take the square root to 2.83. 2.83. You also need to give direction, right? It's asking for the direction. Um, so for direction, you can calculate, let's say this one. Let's call it alpha. Okay, that is alpha. Then use sine law. 5 over sine alpha equals, we got this one being 2.83. So 2.83 over sine 30. So do cross multiplication. So 5 times sine 30 over 2.83. So sine alpha is 0.88. So do sine inverse 62 degrees. So alpha is 62. So this angle is between 3x and 3x minus 5y when they are head to head. But let's remember, right, when they are head to head and tail to tail, they have the same angle. So we can say that 3x minus 5y and 3x are making 62 degrees. But 3x has same direction as x. I can just give direction with x, okay? So 3x minus 5y is making 62 degrees with vector x. We could give the angle between 3x minus 5y and y. So then you could calculate this angle. Again, 180 minus 30 minus alpha would give you that angle. But they are head to, if you find this angle, pay attention. 5y and 3x minus 5y are head to tail here. Then to give the angle, when they're tail to tail, you kind of need to do 180 minus this angle to give that angle. But 1 is enough. Example 3, magnitude of U is given 8 meters, V is 10 meters, magnitude of U plus V is 14 meters. Determine the magnitude and the direction of the vector 2U minus 3V. Okay, so let's do the sketch here. Let's say this is U. Again, I don't know the angle between U and V. I will take it as acute angle, but you know, we may end up with obtuse. We don't know that, right? So let's say U and V, and this is U plus V. Let's say the angle between them is theta. Okay. And at the end, what are we going to find? 2u, 2u, and 3v, 3v. We're going to find 2u minus 3v. So v is negative. Then I start from the head of 3v. That is 2u minus 3v. And that is angle theta. Okay, so let's start with this one. So we are again using this triangle here. So that is magnitude of u plus v is 14. Magnitude of u is 8. Magnitude of v is 10. This angle theta, we don't know, right? But actually I'm not using for the addition, remember? So I'm going to call this gamma. So now we can use cosine law again. Say that 14 square, or if you want to write it with the letters, u plus v magnitude of it squared, magnitude of u square, magnitude of v square, minus 2 times magnitude of u, magnitude of v, cosine gamma. So 14 square equals 8 square plus 10 square minus 2 times 8 times 10 times cosine gamma. So you do these calculations. So 14 square, square. If I move these, so 8 square minus 10 square. This is 32. And this side is negative 160 cos gamma. So then cos gamma is negative 1.1 over 5. And do the inverse. So cos inverse negative 0.2, 101.5. So gamma is 101.5 degree. Then what is theta? Because that's what I need, right? So let's write the magnitude of 2u minus 3v. 2u minus 3v squared. So 2u squared plus magnitude of 3v squared minus 2 times 2u 3v cosine theta using this. So 2u. So again, if I draw this triangle once more, theta. 2u, u is 8, so 2u is 16. V is 10, 3v is 30. And I am looking for the magnitude of 2u minus 3v. Okay, so I need this angle theta. We got gamma 101.5. Then theta is 180 minus 101.5. 78.5. Okay, then I can just replace theta with that. 78.5 degree. Okay, so 2u 16 square plus 3v 30 square minus 2 times 16 times 30 times cosine 78.5 degree. Okay, so 16 square plus 30 square minus 2 times 16 times 30 times cosine 78.5. So this is 964.6. We need square root of that, 31. So magnitude of 2u minus 3v, approximately 31 units. Now the direction. So for direction, if you use this one to find the angle between v and 2u minus 3v, again they are head to tail, then you have to subtract it from 180. But if you find this one, okay, alpha, u or 2u and 2u minus 3v are making alpha angle when they are head to head, means they are making the same angle when they are tail to tail. Okay, so I'm going to find alpha here, alpha, and I got this one, 31. So I can do 31 over sine 78.5 equals, so I'm looking for alpha, so 30. 30 over sine alpha. So 30 times sine 78.5 divided by 31, and I will do sine inverse of that, so that gives me 71.5. So alpha is 71.5. Okay, so 2u minus 3v is making 71.5 degree width. So that is alpha, so v to u, it's vector u. So we gave the magnitude and we gave the angle. Okay, moving on. Example 4. Magnitude of u is 4, magnitude of v is 5. The angle between u and v is 120. So determine the unit vector in the same direction as u. So unit vector, so u hat. So we're going to take vector u and divide it by the magnitude of u. Then u hat is vector u divided by 4. Okay, so this is going to give you 1 over 4 times u vector. So this is what it means, right? So if you have a u vector here, so 4 units, okay, so this whole thing is u vector, then this piece here, u hat. So you multiply u vector by 1 over 4 to get u hat. Okay, b. So determine the unit vector in the same direction as v. So v hat, v vector divided by magnitude of v. So v vector and v hat equals v vector over, so magnitude of v is 5. So 1 over 5 v vector. C. Determine the unit vector in the same direction as u plus v. So first then we need to get u plus v. So if this is u The angle between them is 120. That is an obtuse angle. V 120. So we are looking for the addition. I'm going to draw a parallelogram. So this is the diagonal, U plus V. So magnitude of U plus V is, again, so we can use this triangle here. So this side is magnitude of U, which is 4. This side is V, 5. So we are looking for magnitude of U plus V here. This angle is 120. So what is that angle? Again, extend this. So that is 120. So this angle must be 180 minus 120, gives you 60 degrees. So we do 4 square plus 5 square minus 2 times 4 times 5 times cosine 60. Oops, that is squared. Okay, so then we get 4 square plus 5 square minus 2 times 4 times 5 times cosine 60, 21. So magnitude of U plus V is square root of 21. So I'm going to keep it as exact. Then what is the unit vector that has same direction as U plus V? Okay. Then we divide U plus B, U plus V divided by, I think I can put an equal sign here, divided by magnitude of U plus V, which is root 21. Basically, this is equal to 1 over root 21 U plus 1 over root 21 V vector. Okay, so let's look at example 5. We are given A, B, C, D, E, F regular hexagon. Okay, so what is special about regular hexagon? So you see the shape here. If you draw the diagonals, you get 6 equilateral triangles. Okay, all the sides are same for all of those triangles. Okay, so let A be U vector. So AB is U vector. And FA is V vector. So FA is V vector. Express each vector in terms of U and V. Simplify your answer. So FC, we are looking for FC vector. So we want to represent FC in terms of U, V, or U and V. So as you see, again, this is a regular hexagon, and these are all equilateral triangles. So this vector is same as this vector. So if I call this O, okay, AB vector is same as FO vector. And also, there's also parallelogram, you can see, also same as OC vector. So this is U, that is another U. So looks like FC is 2U vector. So let's look at FB. FB. FB, let me draw it. Okay. FB vector. So this is V, that is U. They are head to tail. So looks like then FB is the resultant of V plus U. V plus U. Or U plus V, doesn't matter which order you get. FD, now we are doing FD. Maybe I should erase some of these so that it is not very confusing here. So this is U. Oops. I shouldn't erase those. FD. At the same time, you may start thinking, how can you get FD? FD. If you go from F to E, E to D, you don't know FE. That's the problem. So you have to follow another way to go from F to D. Okay, again, if you do FE plus ED, we don't know FE vector. Then I'm gonna follow another route following those lines. Okay, so for example, can we do FO plus OD? We cannot. Again, we don't know OD vector. How about if we do FC to CD? FC to CD. Okay, we already know FC is 2U, right? The FC is 2U. We looked at it before. And then if we add this vector CD to it, I can get FD. So CD is opposite to V. So that is negative V. So 2U plus negative V gives me FD. 2U minus V then. Now CA. 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 So can we go from C to B, B to U, B to A, BB plus BA? I could, but I don't know what CB is. So I cannot follow that route. But I can follow this route. I can go C to F, F to A. CF, so FC is 2U, then CF is negative 2U plus V, right? Again, I can go from CF to FA, okay? I can follow this route. This gives me negative 2U plus V. EB vector. EB. So EO is same as V. OB is same as V. So you have V plus V, 2V. BE, so EB is 2V, then BE is opposite to EB, so negative 2V. Now the last one, AB plus BC plus CF plus FA. So you started from A, and these vectors are all head to tail, and you came back to A. Okay, so the result of this is going to be then zero vector. And shortcut would be, even without looking at the shape, but these are gone, C and C, F and F is gone. So you end up with AA vector, which is zero vector.